little bit. Okay, so we're doing 47 on here, and it says find the domain, x-intercept, vertical asymptotes of the log function and sketch the graph. Now I'm going to do this without a calculator, and I'm going to show you how to do it with a calculator. So first of all, 47 does have y. These have function notation, some of them. Put a y in there every time. The first thing I notice is there's no log base. There's no number there. Does anybody remember from the last day what that means the base is? That means the base is 10. So I'm going to go ahead and put a 10 in here. Even though they didn't write it in there, there's a base 10 here. And they didn't put this, but this whole thing is in parentheses, because it's the log base 10 of x over 7. So we don't really know how to graph this without a calculator, but I'm going to show you because we did learn something about these things, didn't we? What did we learn about we could change log to? What form can you change a log to? Exponential. What's the saying? 1, 2, 3. We did it 3 times the other day.
Let's
try it again. 1, 2, 3. So that means 10 is the base of my exponent. What becomes the power of the 10? What becomes the power of the 10? That's the base. Base stays base. The other two do what? Play switcheroo. So let's switch them. What becomes the power of the 10? The y. What goes on the other side? X over 7. Now we want to get the x all by itself. So we're going to get x equals 7 times 10 to the y. That is not 70 to the y. If you multiply those together, you're wrong. That is breaking math law. The rules never change. 10 to the y has a power. It's an exponent. You have to do PEMDAS, which means exponents come before multiplication. So if you take 7 times that 10, you miss it. Now the difference is when you do these and you make your t-chart, the difference is since we've solved for x is by itself, right? We have to plug numbers in to the y. So I'm going to plug in -2, -1, 0, 1, 2, and that's probably enough, but I'm going to go ahead and go to 3. You know, it's not going to take a ton of these. So this is going to be 7, the x value is going to be 7 times 10 to the -2, which would, I hope you remember that means we can move the 10 to the bottom and make it a +2, which is 7 hundredths, 0.07. So I would come over to my graph. Oh no, that's not very straight. Let's try to cheat and use my machine here. Make it so it's prettier. So I got a y-axis, and I have an x-axis, and then I'm going to go, I want to get this. I'm going to go over here, I'm going to say, hey, this is -1, and this one is -2, and we're going to go over here and go 1, 2, 3, and then I'm going to go 1, 2, I really don't even need negatives, but anyway. So 7 hundredths, I hope you know that's just barely to the right, right? 0.07 is barely to the right of the y-axis and at -2. So 0.02 is, or 0.07 is right in here, and I've got to go down. I guess I do have to go down to -2 here, and that dot's going to be pretty close to the y-axis. Then I'm going to plug in -1, so that'd be 7 times 10 to the -1, which would be 7/10 when you move that 10 to the bottom, or 0.7. So 0.7 is out here just past 0.5. I'm going to be at -1. Then I'm going to plug 0 in. So 7 times 10 to the 0 power is 7 times 1, because anything to the 0 power is 7. And I'm going to move this 0 down because these are not lining up like I want. That 0 goes with that. And this -1 goes with that one. So that means I'm at 7, 0. So my graph, I didn't make my graph long enough, did I? I got to come out way out here. Let's see, and then we'll go 4, 5, 6, 7. So 7, 0. There's a dot clear out here. Okay? And then let's plug in one more number. Let's plug in 1. So that's going to be 7 times 10 to the first That is 70. Do we want to go clear out the 7 to get up to 170? You won't make your graph that big? Me either. So this graph is going to go like this. So there's my graph. Now, like always, logs cannot have, everything that goes in here has to be greater than 0. You cannot take the log of a negative number or 0. If you do your calculator and you check it out, your calculator will say error if you hit the log by the 7 and put anything in here other than that. So that means that my domain is going to be 0 to infinity. And I have a vertical asymptote on these, which is usually the y-axis, x equals 0. So these are two other things you were supposed to do up here. Now there's my x-intercept. I got it from plugging numbers in. So my x-intercept is 7, 0. That ordered pair, or you could say x equals 7 if you want the ordered pair. And I already graphed the function, so there's the sketch. Now we can do this. We can do this on a calculator. So I'm going to bring this thing over here. And I'm going to type it in just like it is above. So, where's my calculator? We're going to go to y sub 1 on our calculator. I'm going to clear these out. So I'm going to type in log. Now I can do that over there by the left of the 7. There's the log button by the left of the 7. And that's base 10 automatically. And then I can go alpha y equals 1 and put in x and put in a 7. And arrow to the right in my parentheses. So isn't that what it says? Okay, so I hit graph. So there's my graph. Now, do you remember what I told you about the graphing calculator? Yeah, you start right there and you say this starts at -2 right here, and you don't show that it goes down forever on your picture like my arrow does on my picture, you'll miss it because it goes right along the y-intercept or the y-axis all the way down. It doesn't intercept y. Now, if you want me to show you 7, 0 is your intercept, okay, I'm going to start at 1. Go to my table. Oops, I'm going by too many. I got to go by ones here. I was going by 10s in calculus. So I go to my table. Do you see down there it says 7, 0 right there? So see, all the stuff you need is on your calculator as well. So who's got a question? Yeah.
When you scroll up like the negatives, it says error.
Right. What did I say? What did I just say right up there about when I put
Anything less than 0.
0 or less doesn't work. 0 doesn't even work. If you look at 0, if you go to your table and you go up to 0, see there's an error there. You cannot take the log of 0 or negative. That's why. Yes.
So then how can we find that on the x, y?
Okay.
Why were we able to plug it in?
Okay. Where did I plug the values in?
Into the x and y.
No. Where did I plug them into on this?
Plug them into the y.
I plugged them into the y. This is x values. See, the y is over here by itself. Y can be negative. Y can be negative, but x's can't because it's with the log. The number in here cannot be 0 or negative. It always has to be greater than 0. So because I plugged into y can be negative, but the x's cannot. Okay? Anybody else? All right, so the other stuff is calculator stuff. So we're going to go over here to the at school. We got 57 to 77. This is just typing into your calculator. So if you look right here, you're going to type into your calculator 3 natural log, and then you're going to type 0.74 into your calculator. Do you remember right under log is where ln is? So everybody type 3, and then to the left of the 4, type in ln, and then type 0.474, and round that to 3 places. Somebody tell me what that is? Can't hear you. 3.
-0.903.
All right, there we go. Down here, you're supposed to do these using the properties. Properties. That's these things. Now, do you remember what I told you about? Yeah.
I don't think this is our homework. Maybe I'm wrong, but I thought on the front page today it said 217, 41.
Logs at school notes for Wednesday, Thursday. So this is the at school homework. The other homework is for tomorrow when you're at home. This stuff's for at home. So if you see out here, this is the at home stuff, okay? So this is all going together to turn in on Monday. This stuff's due Monday and Tuesday. Okay. So does anybody remember what LN and E are? Have I told you? LN and E are inverses. It tells you that right there. They cancel each other out. They're inverses. Okay, so first of all, we would want to rewrite this thing, and we would want to move this e to the 2 up, e squared up to the top, which makes the exponent what? And -2, everybody cried, because when you move a power, you change the sign. These two things cancel out, so the whole answer is -2. Now, could you type this into your calculator? The answer is yes. So if you all do this with me, if you all hit LN beside the 4, to the left of the 4. So go LN, and then you're going to type second LN. Oh, wait a minute. Go 1 divided by, and then hit second LN, and that's where the E is, and that E is to the second power. And then enter, you all see, you get the -2 that I just showed you it was. But if you know your properties, it's faster than typing all that in your calculator. And I see I forgot to put the screen back up there. So all I did was type in exactly what it said. Do you see it right here? See it right there? It says LN, well, 1 over E to the second, -2. Yes. Okay, second LN. Okay, anybody? And if there's no power, that means you put a 1 in the box in the exponent. If it just says E, that means it's to the first power. Okay, don't write the 1 up there. So let me see if I can find one of those. Like this one right here, that's E to the first power. So if you look at this, these two things cancel each other out. So on top you got a 1, on the bottom you got a pi. There's your answer. Now if you want to find that decimal, you do 1 divided by pi. The pi on these calculators is second caret. That's above the division symbol. Second caret is where the pi button is. Okay? Coming down here, we are graphing natural logs. So you can just type this into y1. You can say y1 and type in natural log of x plus 5 and get your ordered pairs from your table and graph them. Now again, the domain's the same. This thing in here has to be greater than 0. Now you're going to be able to plug some negatives in for x on this one. There'll be negative values at work because if I plug -1 in there, doesn't that make it still +4? So in other words, your vertical asymptote on this one, your vertical asymptote is what's going to make x plus 5 equal to 0, because you can't do natural log of a 0 because it's still a log. So there's a vertical asymptote at x equals -5. And I go through how to do this on your calculator. You can also take E and raise it to the power on each side if you wish. But you're still going to have decimal numbers. So in other words, these cancel out, and this is x plus 5. And over here you got e to the y power. And then you would subtract 5 over, and you could graph e to the y minus 5, and that would be the same function. Okay? So I want you guys, and up here, this stuff says graph these on your graphing calculator, just like I just talked about this one. So you're supposed to graph these on there and then look at the viewing window. And then here, do you remember the 1-to-1 property? You see we got a natural log and a natural log on each side. Oops, let's do this. When you got a natural log and a natural log, you just drop off the natural logs because these two things have to be equal in order to have them equal. So I put 14 in here. What's 14 minus 7? 7. So in the natural log of 7 going to equal the natural log of 7? You see how that works? Okay, so I'm going to have you do the rest of the time. The rest of the time you're going to be doing your homework. So let's get a start on it.